talking about exponential functions, the graph always looks the same. It's either a curve going up or a curve going down. Okay, there is never anything else to it. It doesn't do any zigzagging. It doesn't have any waves to it. It is strictly either always going up or always going down, and it is curved. It's not a line. And we talked about exponential growth versus decay. What makes something grow? If it's going up, this is growth. It's getting larger. This one is decay. And we can decide that just looking at the problem by the base, the thing in front of the x. So here we had 3 to the x. So 3 is bigger than 1, so that was growth. When we look at this one, we had 2 to the x. 2 is bigger than 1, so that is growth. We had 1/4 to the x. 1/4 is smaller than 1, so that is decay. So we can look at the equation and know, is it going to be going up or is it going to be going down without doing any actual work. Couple other things that we noticed. What is the domain always? Every single problem. All real numbers. Okay, you can plug in any number for x that you want. The range is going to be y is greater than some number. And the asymptote is y equals some number. And these numbers are the same. And they come from whatever is added or subtracted on the end. So if I'm looking back at these problems we did yesterday, this one there's nothing on the end. It's like a +0. So my range and my asymptote were at 0. This one, there's nothing on the end, so it's just +0. So my range and my asymptote were both 0. But this one, we had -1, so my range and asymptote were at -1. All right, let's take a look at this problem, and let's see what we can answer without even graphing it. Can you tell me, is this going to be growth or decay?
Okay.
Right, we're looking at the 1/3. 1/3 is smaller than 1. Anything smaller than 1 will decay. So decay means our graph should be going down. Okay, so I already have in my mind a picture of what it's going to look like. What's the domain? Always. All real numbers. Okay, I know my range is going to be y is greater than something, and my asymptote is y equals something. What is that thing going to be here? 4. And we can see that because I added 4 on the end. So my range, I'm going to get y values bigger than 4. Y equals 4 is going to be that horizontal asymptote. All right, let's graph this. Some of you are getting the right points in your t-chart but not plotting them correctly. So I really want to focus on that today. With our x's, I've told you to plug in a few things. So I usually do 2, 1, 0, -1, -2. All right, everybody, I want you to just pick up a calculator and plug these in. I want every single person plugging them in so that if you're not getting it, we know and we can figure out what you're doing wrong. When you put this in, put it in exactly as it's written. So the 1/3 is in parentheses, then you put your exponent, and then you do the +4. You are welcome to give me decimals here because in terms of graphing, it might be easier for you to see where something goes on your graph with a decimal. So that does not matter. When you put in -2, what does that give us? Or sorry, when you put in +2, what do we get? 4.1. Okay. If I'm going to graph that, everyone look at our graph. This is 0, 0. X is left and right, so we go right to, my y is 4.1, so up 4.1, so just a little past the 4. All right, now go back and plug in a 1. So 1/3 to the first plus 4. we get?
4.3.
So positive 1, 1, 2, 3, 4.3 is just a little higher than 4.1. All right, put in 0. What do we get?
5.
So 0, 1, 2, 3, 4. 11. Okay, if you put in -1, what does that give you? So -1, go left 1 and up 1, 2, 3, 4, 5, 6, 7. And -2. We plug in -2. What do we get out?
13.
So left 2, up 13, which takes us off our graph. Okay, here's what else I want you to do. Our asymptote is what we're getting close to. We can see these points are getting closer to 4. That's what we put down here. I want you guys to draw a dashed line at 4. And when you graph it, don't cross that. That is your stopping point. So that dashed line is telling you, this is where your graph ends. Do not go past this. And then we draw our curve. It's just going down and then getting closer to this line without crossing it. Arrows on the ends, it keeps going both directions. And that matches what we said originally. If we said it was going to be decay, so it should be decreasing, and it is. All right, the only question we have not answered on this yet is the y-intercept. That is where we hit the y-axis. So if I'm looking at this graph, where did it hit the y-axis? At 5. It's always that point when your x was 0. So it's the point 0, 5. Any questions there? I look at this. Growth is decay is decided by the number in front of x. The number in front of x is just 2. So what is this one going to be? Growth. So I know it should be a curve going up. That's what my graph's going to look like. All right, what's the domain? Always. Okay, my range should be y is greater than something. Asymptote is y equals something. What are we adding or subtracting on the end? We don't have anything. So what does that mean? 0. My range is going to be y is greater than 0. My asymptote y is equal to 0. All right. Let's make our t-chart and graph this. So if I put in a 2, I'm typing this in my calculator. 1/4 times 2 to the second power. What do you guys get out? So 2, 1 is a point on the graph. We go right to up 1. Is everybody getting these when you plug them in? You know how we're getting them. All right, if you plug in 1, so 1/4 times 2 to the first, what do you get? 1/2 or 0.5. So if we go right 1, up a half. If I put in 0, 1/4 times 2 to the 0. Okay, if I put in -1, 1/4 times 2 to the -1. 1/8. This one's giving us really small numbers, isn't it? Okay. If we put in -2, we get 1/16, which is really hard to graph, but we've got this shape. If you needed more points, you are welcome to go ahead and plug in like a 3 or a 4 if you wanted to see. We already said our asymptote is at 0, so I want you to draw a dashed line at 0, and you cannot cross that. All right, so my graph is going up like this, and it cannot cross this line. So that's my exponential growth. Y-intercept, it's where we cross the y-axis, or if we look at our table of values, it's when x is 0. So that was the point 0, 1/4. Can you tell me if it's growth or decay? Decay. You're looking at the number right in front of x is smaller than 1, so this will be decay. So we know that our graph is going to be falling. Domain is always all real numbers. Okay, range is going to be y is greater than, asymptote y is equal. What is that number going to be? -3, because we're subtracting 3. And you could even go on your graph right now and go to -3 and draw a dashed line. We cannot cross that when we are graphing. Okay. Any issues so far? So now for our t-chart. If we plug in 2, what did that give you out? -1.75, is that what you guys got? So I have go right 2, down 1.75. If I put in 1, I get -0.5 or -1/2. So right 1, down 1/2. If I put in 0, we get 2. 0, 2. If I put in -1, we get 7. 7. If you put in -2, we get a huge number, don't we? 17. So it's way off the graph. Now, this might be enough. You can't necessarily tell from this that we're getting closer to -3. We knew that. We could plug in more numbers if you wanted, if you weren't sure. Like if you put in a +3, then you would have 5, 8, 6, 16. And so then that would get us closer. Something. And that would get us closer, but we already know it's a -3 because of the equation. And so our graph should look like this. You get closer to that line, but you don't ever cross it. How are we doing with this? I'm going to hand back your papers from yesterday. A couple of you never did. What's my y-intercept on this one?